Today's mini lesson is going to be talking about equations. Let's first off define what an equation is. An equation is formed by placing an equal sign between two numerical or variable expressions. Alright? Okay, we're ready to move on. Just kidding, I'll explain it just a little bit more. If you have an equal sign, that means it's an equation, basically. Okay, we're going to move into other things where they're not always an equal sign, but right now we're going to be working with things that have an equal sign. If you have an equal sign in between numbers, like 2 and 4 here, or variables like the x, then that makes an equation. Okay, so here are two examples of equations. X plus 2 is 4, x plus 5 equals 5 plus x. They both have variables and numbers, and they have an equal sign, so we have equations. Alright, let's look at how we can use equations or make equations. The first question is number 6 on page 11. And this is looking at an equation, and you'll see here we have a set, just like we had yesterday. We're going to solve this equation. Okay, we're going to solve for what x is equal to using this set. And we've done a question almost just like this yesterday with the sets. But let's go ahead and do that. 6 minus x is equal to 3. So we can plug in all these numbers. 6 minus 0 equals 6. 6 minus 1 equals 5. 6 minus 2 equals 4. I mean, we can do this. With this type of equation, it's almost, we can almost guess just by looking at it. And how many more do we have? Whoops. I went backwards. I started talking and typing at the same time. Alright, and 6 minus 5 equals 1. 1. Alright, and so we can see that the one we have that is correct, I've put a little square over it right there. 6 minus 3 equals 3. And so what we did, we just plugged the x values from our sets, 0, 1, 2, 3, 4, 5, and we found that that is the right answer there. So this one here is correct. Therefore, x is equal to 3. Alright, that is how we would solve this equation using the set up here. Now let's create some equations. We are told that 3 less than a number is 3. What is that number? 3 less than a number is 3. What is the number? Now, this question, comes from page 12, and it's question number 24. And I think what we're just asking for is what the equation is for this sentence. We're just transforming. We're starting to use words to make up phrases. So the first thing that we're going to do is take a look at what it says. 3 less than a number. When you're told a number, let's underline that there, a number. What we're going to do is just write x for that number. Okay? There's our number right there. Now we're saying 3 less than that number. So the way that we would write that, I'm going to continue to underline here. Whoops. That should have been a different color. Wow, this background is not a great color to work with. Okay. 3 less than x would be x minus 3. I hope your eyes are good. If not, you won't be able to see this. Saying 3 less than a number is saying that number, x minus 3, and we're saying is 3. And I'm going to pick a really dark color to draw this line here. Is 3. The way that we would write that would be equals 3. All right. So the way that we would write this equation for question number 24 on page 12 is x minus 3 is equal to 3. Okay, 3 less than a number is 3. And we can solve for that if we want to. If we were given a set, we could actually go through and solve those, punch in some numbers and figure out which one it is. But we're not given a set. Now, if you look at this, you can probably say, yeah, 6 minus 3 is equal to 3. So you could actually find what that number is. X is equal to 6. But I'm just trying to check real quick whether the question is actually asking us to do that. Yeah, it is. The question is actually asking us what the number is. So when we look at that, we say, what number minus 3 is equal to 3? Well, 6 minus 3 is equal to 3. And so therefore, x is equal to 6 there. Okay? So that's the type of working words into equations and then solving. All right? Let's go ahead and look at the next one. Oh, we are given a set. I'm just looking in the textbook. We are given a set for this actually as well. So, sorry. Let's look at question number 25. We're also given a set for this, and I should have written it down. The set is 0, 2, 4, 6, and 8. There. And we are asked in question 25 to come up with the number 3 more than twice a number is 7. Oh wow, that sounds a little bit complicated, and it is a little bit more than the last one. So let's go ahead and do some underlining so that we can figure it out. First off, we have a number. I really like this. A number. That means we can write x. Okay? We don't know what we're doing with that number yet, but we have a number, and it's x. Okay. 3 more than twice a number is 7. Okay. First off, twice a number would mean 2 times that number. So we can write that in. Twice is equal to 2 times. Okay. And the way that we would write that, we can write that with using parentheses. Oh, wow. Okay, so twice a number is like saying 2 times a number. And you're saying 3 more than twice this number is 7. Okay, well, we know is 7 means equals 7. And 3 more than would be addition. Okay, we're adding 3 onto something. Okay, so if I'm going to stay consistent here with my numbering system, there. Okay, so 3 more than twice a number, so 2 times a number plus 3 is equal to 7. And what we can do is start plugging in numbers from our set here to try and solve and find out what x is. Alright, so we can go ahead and do that. 2 times 0 is 0 plus 3 is equal to 3, so it's not that one. Let's try the next one. 2 times 1 is 1 plus 3 is equal to 5. So it's not that. Let's try the next one. 2 times 2 is 4 plus 3 equals 7. So that one's right. Let's see if it works out for any of our other ones. 2 times 3 is 6 plus 3 is equal to 9. And, oh my goodness, look at what I'm doing. I'm not even following our set. 2 times 4 is 8, plus 3 equals 11. 2 times 6 is 12, plus 3 equals 15. And 2 times 8 is 16, plus 3 equals 19. Alright, and because I didn't follow along, it should have been 0, 2, 4, 6, and 8. There we go. Alright, so the number that worked in this case was 2. So we can say it didn't work for any of the other ones, therefore x is equal to 2. That's the solution to this question. Okay. Let's do one more. Sometimes you'll be asked, they'll throw in a word like domain. Okay, what the domain means is it's just another way of saying that this is our set. Okay, you'll see domain used later on, and you don't have to worry about what it is right now. It's just another way of saying a set like this. So solve over the domain of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So one of these numbers will be the solution for n. And we'll just go ahead and start plugging those numbers in. And this may seem a little bit redundant, what I'm doing here, but you'll see that it does pay off to do all of the steps in questions. Alright, so you see what I'm doing here. I'm just plugging in the numbers from the domain, or from our set. 5 plus 5 times 0. 5 times 0 is 0, plus 5 is 5. 5 times 1 is 5, plus 5 is 10. 5 times 2 is 10, plus 5 is 15. You can probably see a pattern here. That we are going to be increasing by 5 each time. 5 times 5 is, or 5 times 3 is 15, plus 5 is equal to 20. 5 times 4 is 20, plus 5 is 25. And so this is going to take us a little bit of time. We can tell that we're not going to get there. And if you are going through this and saying, wow, Mr. Buffington sure is taking a long time, when I look at this question, I go, well, it's increasing by 5 each time, so I know it's not going to be the next one. All right, it's not going to be 45, but it will be the one after that. And if you want to say, you know what, I'm smart enough that I can go ahead and skip a step here. And if at any time while you're doing this you start noticing patterns and you want to just skip a step, as long as you're solving completely and finding the correct answer, it's okay to skip steps doing this. All right? As long as we find the correct solution when we're doing our sets, and we are substituting in a couple of them. Okay, if you substituted maybe the first 3 and you said, oh, I see a pattern here, it increases by 5. So I'm just going to skip a couple and maybe go try 7 or try 9. Okay, and you'll end up with the right answer at the end. That's great. Okay, those kinds of shortcuts are good, as long as we're not skipping steps when we're doing work. So there's a solution for this one. Question number 32 on page 12. So whenever you see an equation and you're given a set, just go ahead and start substituting the set into the equation. So 0 is for n, 1 is for n, 2 is for n, 3 is for n, and do the math until you find the solution for the equation. That is our mini lesson for today, and have a wonderful afternoon or morning.